Last video we defined and explained what are equations, the two sides of an equation, and then we explained what is a solution, which is what makes the one side equal to the one side. So a value of the variable that makes one of the sides to be equal to the other side, okay, or both sides to be equal. Then we explained that some equations may not have solutions, some may have a single solution or a number of solutions, and then some may have infinite solutions. Right. Then we explained that there are two main different types of equations. Right. Equations that have a finite number of solutions, and then we have equations that are true for all values of the variable involved, and those are called identities. Then we also explained that there are certain operations that you can do on equations. In fact, you can do any operation on the equation as long as what you do on the left you also do on the right the same way. That way the equation remains valid. Then the most important of the operations that you do, we explained that to transpose any terms that are added or subtracted, you can transpose them. You can take them across the equal sign to the other side. And when you do that, you must change the sign. And then if you have a coefficient that you want to remove on a term, you can just divide all the terms on both sides by that coefficient of that term. And then the coefficient of that term will now be 1. So all of that will help us to be able to solve linear and quadratic equations. So we will start with linear equations. Right. So solving linear equations. So let's start by explaining what are linear equations. Linear equations are equations where the exponent of the variable is 1, or the exponent of all the variables involved is 1. And now we will deal with linear equations where you have only one variable right now. And then even with quadratic equations, we'll be dealing with quadratic equations involving one variable. Then later on, we will do linear and quadratic equations that have two variables. Right. These equations where there's one variable are called univariate equations. All right. Now, let's take examples of linear equations. What are examples of linear equations? So 2y minus 3 equals 7 is an example. The exponent of the y is 1. Then 2 into 7 plus 5y equals 124. It's also a linear equation because even though there seems to be multiplication, we are multiplying only by a constant. 2 times 7 will be 14, and this will be 10y. The exponent of the y will still be 1. Right? Then let's take another example. 5x is equals to 2x plus 4. And then let's take another one. Negative 3y is equals to 0. This is a linear equation because we have what? Exponent of the variable involved is 1. Even here is 1. This one is a linear equation because the exponent of the variable involved, which is y, is also 1 once again. Then let's take another one. 55 is equals to 5x plus 3/4. That is still linear equation because for the variable involved, the exponent is 1. And lastly, let's say we have 4 over p equals 16 over 24. This is a linear equation because if we simplify this by cross multiplying, this is going to be 16p and this is going to be 96. So the p will still have exponent 1. Okay, so those are all examples of linear equations. Now, let's go on and solve the equations. Now, in order to solve linear equations, the steps are not a lot. Step number 1 is simplify on both sides. On both sides. Step number 2, take all variables to one side, variable terms to one side, and constants to another side. Step number 3, add like terms. And then step number 4, divide both sides. Divide both sides by the coefficient of the variable. So let's explain this, or let's go through the steps again. You first simplify on both sides of the linear equation that you have. Once you have simplified, you will have individual terms added together. Then you take all variable terms, in other words, the terms that have the variable that you have, x, y, or whatever, to one side, and the constants, in other words, the terms that do not have variables, to another side. Then from there, you add them terms on each side together. Then you'll be left with one term on either side of the equal sign. Then you divide both sides by the coefficient of the variable. So let's do some examples. So we have 6 examples there. Let's take the first one. So we want to solve 2y minus 3 is equals to 7. So to solve this, first of all, if you just guess the solution, the solution for this will be the y that will make this side to be equal to that side. And if you guess, going from 1 up to 5, you'll realize 5 is the solution, because 2 times 5 will be 10, minus 3 will be 7. So we know for sure the solution is y is equals to 5 by guessing. But if we want to do it step by step, we will use what we know about operations allowable on equations. But also we could just follow the 4 steps that we have established here. So how do we solve this? The first step is to simplify, right? This is already simplified because we have individual terms added together. All right. Then the second step is, after simplifying, you have to take all the variables terms to one side and the constants to one side. We have a constant here, so we have to transpose it. When you transpose, remember, you change the sign. So we're going to have 7 plus 3. Now, that gives us what? 2y is equals to 10. So we have individual terms on either side now. So what do we do? The next step is to divide by the coefficient of the variable. The coefficient of the variable is 2 in this case. So then the answer is 5, because 2 goes into 10 5 times. Okay. So indeed the solution is equals to 5. Let's take another example. 2 into 7 plus 5y is equals to 124. Now, if we want to solve this, we first simplify. Multiply this here, multiply it there, you get 14. Multiply here, you get 10y is equals to 124. Now that we have simplified and we have individual terms, we take the variables to one side, constants to one side. We have only one variable term, so we'll transpose the 14. We'll take it to the other side. And remember, when you transpose, the term needs to change the sign. So we're going to have 124 minus 14. Then we have what? 10y is equals to 110, because 124 minus 14 is equals to 110. And now that we have transposed and added the like terms, and we have individual terms on either side, we divide by the coefficient of the variable term. And that gives us y is equals to 11, because 10 goes 11 times into 110. If we go on and do example number 3, we're going to have 5x is equals to 2x plus 4. Now, we simplify on both sides. This is already simplified because we have individual terms added together, right? Now, that means that we can go to the next step. We take the variables to one side and the constants to the other side. So that means you have to transpose the 2x. So it's going to change the sign. It's going to be negative now. So we have 5x minus 2x is equals to 4. After transposing, we add the like terms. Here already we only have one term. Here we have two terms. When you add this, you get 3x. Now, once you have added the like terms, you have it individual, one term on each side. So you can divide by the coefficient of the variable. Then we get what? X is equals to 4/3. Right. So that's the solution. And then let's go to negative 3y is equals to 0. Now, in this case, there's no need to simplify because we have